Everything you have ever seen, every star, every galaxy, every atom in your body, adds up to just 5% of the universe. The other 95% is completely invisible, and we have almost no idea what it is. We have given the two great unknowns names: dark matter and dark energy. Tonight, we go hunting for the missing universe. Let us start with what we can see. Ordinary matter, the stuff of planets, stars, gas, and people, is called baryonic matter. For centuries, we assumed it was essentially everything there is. But in the 20th century, the sky began telling us a very different and very unsettling story. In the 1930s, the astronomer Fritz Zwicky studied a great cluster of galaxies and measured how fast they were moving. They were racing around far too quickly. The visible matter in the cluster did not have nearly enough gravity to hold it together. By all rights, the cluster should have flown apart long ago. Zwicky suggested there must be some unseen mass, some dark matter, providing the extra gravity. His idea was largely ignored for 40 years, until, in the 1970s, an astronomer named Vera Rubin turned her attention to how individual galaxies spin. Rubin measured the rotation of spiral galaxies, expecting the outer stars to orbit slowly, just as the outer planets orbit the sun slowly. Instead, she found the outer stars moving just as fast as the inner ones. The galaxies were spinning so fast, they should have torn themselves to pieces. The only way to explain it was to assume that every galaxy is embedded in a vast, invisible halo of dark matter, far larger and heavier than all its visible stars combined. That unseen halo grips the galaxy with its gravity and keeps the whirling stars from flinging away into the dark. This was no longer a fringe idea. Vera Rubin had shown, galaxy after galaxy, that something enormous and unseen was there. The visible universe was just the tip of a cosmic iceberg. For every pound of ordinary matter, there seemed to be roughly 5 pounds of this mysterious, invisible dark matter. But how can you be sure something is there if you cannot see it at all? The answer is gravity, and one of its strangest effects. Einstein showed that mass bends space, and that bent space bends the path of light. A heavy enough object acts like a giant lens. When we look at distant galaxies, we sometimes see their light smeared into arcs and rings, warped by the gravity of something in front of them. By measuring that warping, we can weigh the invisible mass doing the bending. And again, there is far more mass than the visible matter can account for. The most beautiful evidence of all comes from the bullet cluster, where two galaxy clusters have smashed through one another. The visible gas piled up in the collision, slowed by the crash. But the gravity, measured by lensing, sailed straight on ahead, exactly where invisible dark matter would be, passing through untouched. So dark matter is real. It outweighs ordinary matter 5 to 1. It forms an invisible scaffolding on which every galaxy is hung, the hidden framework of the entire cosmic web. Without it, galaxies would never have formed at all, and neither, in the end, would we. There is one more powerful witness, and it is the oldest light in existence. The cosmic microwave background carries a delicate pattern of ripples, frozen sound waves from when the universe was a newborn. The precise spacing of those ripples can only be explained if dark matter was already there, shaping them, from almost the very beginning. Dark matter also solved a deep puzzle, how galaxies formed so quickly after the Big Bang. Ordinary matter alone simply could not have clumped together fast enough. But dark matter, feeling only gravity, began gathering into dense clumps very early, carving out the wells into which ordinary gas later poured to ignite as the first stars. There is just one small problem. We have absolutely no idea what it is made of. It gives off no light. It does not glow, block, or reflect. It appears to pass straight through ordinary matter and even through itself, feeling only gravity. Right now, billions of dark matter particles may be streaming through your body, and you would never know. The leading suspects are entirely new kinds of particle, ones not found in any of our current theories. Some physicists favor heavy, sluggish particles, nicknamed WIMPs. Others favor a feather-light particle called the axion. Each would be a completely new ingredient of reality, hiding in plain sight all around us. So we have gone hunting. Deep underground, in old mines and beneath mountains, shielded from all interference, sit exquisitely sensitive detectors, waiting in silence for a single dark matter particle to bump into an ordinary atom. We have also searched for it in the debris of our largest particle colliders. And so far, nothing. Decades of searching, ever more sensitive experiments, and not one confirmed detection. Dark matter remains stubbornly, maddeningly invisible. It is one of the greatest unsolved mysteries in all of science, and it makes up a quarter of everything that exists. Not everyone is convinced dark matter even exists. A bold minority of scientists argue that instead, our very law of gravity is subtly wrong on the vast scales of galaxies. This idea, called modified gravity, can explain how a lone galaxy spins. But it struggles badly with clusters, and especially with the bullet cluster, where matter and gravity were clearly seen to part ways. But dark matter, as strange as it is only part of the missing universe. Because in 1998, astronomers went looking for something else entirely, and stumbled onto a discovery so shocking it would earn a Nobel Prize and rewrite the fate of the cosmos. Two teams were measuring how fast the expansion of the universe was slowing down. Everyone expected it to be slowing, dragged back by the gravity of all its matter. The only question was how much. They used exploding stars, distant supernovae, as cosmic mile markers to measure it precisely. The answer stunned them. The expansion of the universe was not slowing down at all. It was speeding up. Something was pushing the galaxies apart, faster and faster, overpowering all the gravity of all the matter in existence. That mysterious something we now call dark energy. Dark energy appears to be a strange kind of pressure woven into empty space itself. The more space there is, the more dark energy there is, and the harder it pushes. As the universe grows, dark energy grows with it, and its grip on the cosmos only tightens. And here is the truly humbling part. Dark energy is not some minor detail. It is the single largest component of the universe, making up around 68% of everything. Dark matter is about 27%, and everything we can actually see and touch is the last, thin 5%. Our best guess is that dark energy is the energy of the vacuum, of empty space itself. Quantum physics predicts that even perfect emptiness should seethe with energy. The trouble is, when we calculate how much, we get a number too large by a factor of 10, followed by 120 zeros. It is often called the worst prediction in the history of physics. Our finest theory of the very small and our finest observations of the very large disagree by the largest margin in all of science. Somewhere in that gap hides a secret about reality that we have not yet begun to understand. Dark energy does not just puzzle us, it will decide how the universe ends. If it keeps pushing at its current rate, the galaxies will drift ever farther apart, the sky will slowly empty, and the cosmos will fade into cold, dark, endless expansion. A quiet ending written by something we cannot see. And if dark energy grows stronger over time, the ending is far more violent. It could eventually tear apart galaxies, then stars, then planets, and finally atoms themselves in a runaway catastrophe some call the Big Rip. The fate of everything rests on the nature of a substance we have never identified. Step back and take in the full picture. 95% of the universe is made of two things we cannot see, cannot make in a laboratory, and cannot truly explain. Every star and galaxy and person is a faint, luminous froth, floating on a vast, dark ocean whose depths we are only beginning to glimpse. For most of history, we thought the glowing things in the sky were the universe. Now we know they are the exception, a rare and brilliant minority lit up against an overwhelming darkness we have barely named. The cosmos turned out to be far stranger and far larger than the part we can see. And yet, on one small planet, a species of curious apes has managed to weigh the invisible, to map the dark scaffolding of the cosmos, and to measure a pressure hidden inside empty space. We do not yet know what most of the universe is, but we have learned to see its shadow. And that is where every great discovery begins. Thank you for staring into the darkness with us tonight. If it left you a little more curious about the 95% we cannot see, then consider subscribing and join us for the next journey. Until then, keep looking up and stay spaced out.